Alrighty. Good afternoon or good morning, whatever time you are seeing this. I hope you're having a good day. And so for 9.3, this is the end of activity 9. We're going to graph and write the inverse of cube root functions. We're going to find the inverse relations of cubic functions because cubic and cube root are related to each other. They're inverses of each other. So far you have graphed and found inverses of linear, quadratic, and square root functions. You discovered a number of patterns related to these types of functions. So get your highlighters ready. We have learned that linear functions have inverses that are functions as long as the line, sorry, my brother's trying to call me, as long as the line is not horizontal. Because the inverse of a horizontal line is a vertical line, and a vertical line is not a function. It doesn't pass the vertical line test. So again, it says recall, vertical line is not a function. All right, we've also learned some things about square root functions. They always have inverses that are functions. You find the inverse of a square root function, it'll be half a parabola, and that will always be a function. Quadratic functions, on the flip side, though, they are functions, but their inverses will only be a function if we restrict the domain. Otherwise, the inverse is a relation only, because if we don't restrict the domain, the inverse of a parabola is a sideways parabola, and a sideways parabola doesn't pass the vertical line test. But if we restrict the domain on the parabola so that only half of it shows, then when we find its inverse on just that half, it'll only be either the top half or the bottom half of the sideways parabola, and that will pass the vertical line test. All right. We also know that any function that is one-to-one will have an inverse that is a function. So to be one-to-one, remember that is a function that passes both the vertical and horizontal line test. If a function is not one-to-one, then its inverse is going to be a relation only. It won't be a function unless we restrict the domain. Okay. But this is before we fix it to make it work. Okay. So now we're going to explore cube root and cubic functions to see if patterns exist. It says to study the graphs below, each cubic graph in the bottom row is the inverse of the cube root graph above it on the top row. The graphs in the center and right-hand columns are translations of the graphs of the parent functions in the left-hand column. Okay, so if we're taking a look at all of these, we have the cube root of x and its inverse, x cubed. These are inverses of each other, so I want to highlight that. Cube root of x is the inverse of x cubed. When we shift the cube root of x up 4, its inverse gets a 4 movement with a number 4, but going up is a positive move, so going to the right on its inverse would be also a positive move. So it's an up 4 on the original function, but it's a right 4 move on the inverse function. Okay, so let's mark that. This plus 4, it's on the outside, so it means up 4. I know that a lot of you guys struggle with that. In the parentheses means it's to the right. So right 4. Okay. Now this one has a lot more going on. Has a minus 3 under the radical and a plus 5 outside the radical. So it means it went to the right 3 and up 5. And its inverse is going to have the same type of movements, but you know how we Freaky Friday these? We Freaky Friday them on the inverse too. The horizontal and the vertical move. Okay. So going up 5 was a positive vertical move. So when we find its inverse, it will be a positive horizontal move. So x minus 5. Minus 3 is a positive move to the right 3 units. So that means we have to do a positive move on the flip side, though, vertically for the inverse. So this minus 5 is to the right. And this plus 3 is up. Okay, so their horizontal and vertical movements are also Freaky Friday'd when we find a function and its inverse. Oops, I keep bumping this. Also, something that we learned when we were looking at cube root functions and cubic functions is that all of these pass the vertical and the horizontal line test. So I want you guys to write that in your notes. All of these graphs pass both, put that in caps and double underline it, the vertical line test, VLT, and the HLT, horizontal line test. Okay, so that means that these functions are all one-to-one because they pass both tests. Turn the page. All right, Alex says that cube root functions and cubic functions are not one-to-one. Is Alex correct? Well, what did we just say, you guys? You already had the answer to that. Is Alex correct? No. Both cubic and cube root relations pass both the VLT and HLT. So they're, like they are, 1, 2, 1. All right, number 2, it says give the domain and range for each of the functions and their inverses. Well, remember that cube root and cubic functions have the same domain and range, and that is all real numbers. So their DNR is all reals. Number 3, make a conjecture about the inverses of cube root and cubic functions that are translations of the parent functions, f of x equals the cube root of x and f of x equals x cubed. Okay, so while we know that their translations, their horizontal and vertical moves were Freaky Friday, and we know that when we translate them up, down, left, or right, these are still going to be inverse relations of each other. They're still going to result in functions. So we can say the inverses of the translations will always result in functions. So no matter where we move them, up, down, left, or right, anywhere on the graph, they will still be a function. It will still pass the vertical and horizontal line test. They'll still be one-to-one. All right, so you may have noticed another pattern. The inverse of a translated cube root function is a translated cubic function. Since finding inverses involves interchanging x and y values, hello, Freaky Friday, the vertical and horizontal translations are also interchanged. Hello, I already said that. You can verify this with an example. So they go through an example of that. It says find the inverse function f of x equals the cube root of x minus 6 plus 1. So you saw it graphically. Now let's see it algebraically so you can see what's happening for yourselves, because a lot of the times we see it on the graph and we're like, that doesn't make any sense. But when we see it with algebra, we're like, oh, okay, that's why. All right, so let's identify what these movements are. Minus 6 on the inside of that radical means it was moved to the right 6. Plus 1 outside means it was moved up 1. Okay, so let's Freaky Friday. Change the f of x to a y, switch x and y, solve for y. So they switched f of x to a y, they Freaky Friday'd, and now they have to solve for y. So they subtracted the 1, so that's why it's over here, negative. They have to undo the cubed root by cubing both sides. That's what they did here. Poof, y minus 6 comes out, x minus 1 quantity cubed, and then add the 6 to the other side, and we get y equals x minus 1 quantity cubed plus 6. So we can see that this switched to a movement right 1 and up 6. So right 6 up 1 switches to right 1 up 6. So if it's a positive move to the right here, it'll be a positive move up here. If it's a positive move up here, it'll be a positive move to the right here. So up and right are opposites, and down and left are opposites. Okay. All right. Not all cube root functions or cubic functions are translations of their parent functions, so you need to examine those as well. So not all of them are going to be written so that we could tell if there's a translation or not. Translation is a movement, left, right, up, or down. So sometimes we need to be very careful about that. So try these A. There are 2 ways to do these 2 problems. You can Freaky Friday them out algebraically all the way by hand. Or you could do it the shortcut way. I'm going to do them both the 2 different ways. So I'm going to first do it the Freaky Friday way. Let's put letter A up here. F of x equals the cube root of x plus 3. Freaky Friday it. So I switched f of x to a y. And now we need to Freaky Friday, switch places, x equals cubed root, y plus 3. I have to undo the cube root, so I have to cube both sides. That's the only way that those can cancel. So x cubed equals, poof, y plus 3 gets to come out. Subtract the 3 from both sides. And y equals x cubed minus 3. So f inverse of x equals x cubed minus 3. Okay, so I know that that's what the answer is. These are inverses of each other. Well, now let's go back to here, since I didn't write anything there. And let's notice that this is a movement to the left 3. Well, then its inverse is going to have that same translation, but instead of to the left, the opposite of left would be down, because that's a negative move. It would be down 3. So it'd just be cube root of x down 3, so minus 3. Oh, sorry, not cube root. Oh my gosh. The inverse of cube root is cubic, so x cubed. I totally screwed that up, but that's okay. I'm human, I make mistakes. So they end up being the same thing. So you can either know and identify the movement and then know that you just need to Freaky Friday the movement. Opposite of left is down. Or you can continue to do it by hand, Freaky Friday, and you'll still get the right answer. This only takes a little bit longer. But these, like, once you get the hang of it and it's just so quick, it's kind of nice when it flows so quickly. We don't have to waste time on it. All right, let's try letter B without doing Freaky Friday the long way. Let's do it the quick way. And I promise I won't screw it up this time. So plus 5, this is up 5, okay? So the opposite of up is to the right. That's also a positive move. So f inverse equals, the inverse of a cube root is a cubic, so that's x cubed. But we're moving it, instead of up 5, we have to inverse that, so it will be to the right 5. So I actually need to put x minus 5 quantity cubed. And that's what it would be. And if you Freaky Friday it and you do that by hand, you're going to get that same exact thing. All right, number 4, it says to use a graphing calculator to investigate f of x equals the cube root of x squared plus 4x in a standard 10 by 10 viewing window. Sketch the graph. Is f a one-to-one function? Why or why not? Will the inverse of f be a function? All right, so I'm taking you to my computer. I have Desmos pulled up. Let me grab my mouse real quick. Oh, all right. Sorry about that. All right, so we need to type in that function. It says f of x equals, but we don't have f of x here, so you have to type in y. Y equals, and then it says the cubed root of, so cubed root in here, does this have cube root? I might have to do it a different way. Let me see, the keyboard. I have square root. Any other functions? Let's look at miscellaneous. Oh, I do. I have the nth root there. So I'm going to You see where my cursor is? Nth root. So I could pick any root I want. Okay, so it lets me do it. So I'm going to do the cubed root of, it wants x squared plus 4x. So x squared plus 4x. Look at that. It looks so funky. Okay, so looking at that graph, what did it want us to say? It says to sketch the graph. So we need to draw a picture of this. Is f a one-to-one function? Why or why not? Okay, well, let's try this. So let's graph it. I'm going to put it over here. Oh, but where you guys can see it. All right. I know that it's crossing through the x at -4 and 0. 1, 2, 3, 4, and 0. And we have a point at -2, 1.5, -1.5. So about right here. And it does this weird thing. Okay. Well, we know that this is not going to be one-to-one because it passes a vertical line test, but it's not going to pass the horizontal line test because it's going to cross through 2 times at once. So it's not one-to-one. So its inverse is not going to be a function. So I can say it is not one-to-one. So its inverse won't be a function. Okay. Investigate the cubic function g of x equals x cubed minus 6x squared plus 8x plus 5. Use your calculator to graph g in a standard 10 by 10 viewing window. That just means from -10 to +10 on the x and the y. Sketch the graph. Is g a one-to-one function? Will the inverse of g be a function? All right, let's try it. So I'm going to grab my phone again. It's actually my husband's phone because my phone's uploading videos. So y equals, it is x cubed, shift 6 cubed, bring the arrow down, and then I lost it, minus 6x squared, bring the arrow down, plus 8x, plus 5. And can I make this one not show? Yes, I can. Just click on it. All right. Let me change my window. Let me show you how to change the window. You go to the wrench, and then it's up here. There's the wrench. And then you go to the x-axis, and let's make this, oops, -10 to +10, and the y, -10, come on, to +10. And there we go. And then that's what we see. Okay. Is this one, this is a cubic function. Is it one-to-one? Is it going to pass both the vertical and horizontal line test? Well, it'll pass the vertical, but is it going to pass the horizontal? Just imagine holding a horizontal line through there. It's going to cross through 3 times. Only allowed to cross through once in order to pass. So no, it is not one-to-one. And we won't draw the picture this time. So we'll say not one-to-one. So its inverse is not a function. It's got to pass the vertical line test to be a function, and its inverse will not, since the original is not passing both tests. The next page, and oh, look at that. I believe we are done. Yep, we are done. So your homework is going to be on this page, numbers 9 through 13. Have a good one.